Hey guys, welcome to the video for evaluating functions and sequences. Our essential question is, how is the language of math communicated? So this video is probably going to be broken up into two parts, so I will go over the evaluating functions part and then the sequences part in a separate video. Alright, so our vocabulary. Function. Okay, let's define this real quick, and I'll kind of explain it a little bit later. But a function is for every input there is at most one output. So for anything I put into my function, the most I can get out is one output. If I get more than one thing out, it's not a function. So for example, it's kind of a weird example, but let's talk about this. Let's talk about the square root of x. And let's pretend I plug in the square root of 25 in for x. So instead of x, now I have 25. What is the square root of 25? And you're probably thinking, oh, 5, because 5 times 5 is 25. Square root means it has a number that is multiplied by itself that I can get if I square root it. So it's 5. However, doesn't negative 5 times negative 5 also make positive 25? It does. So in this case, this isn't really a function because I get two different answers. So when I square root something, I get two different answers. And so in this case, when I input 25, I'm getting two outputs. I'm getting 5 and also negative 5. So moving on, we have function notation, and I'm just going to kind of give you an example of what this looks like, not really define it for you. So for example, we've seen like y equals 3x plus 5. This is a function. There's an input and an output. We put something in, we can take something out. So for example, I can plug in something for x, and then I do the math, and I get something out for y. Now, function notation is basically replacing that y and putting f of x in front of it. So f of x equals 3x plus 5. So everything is the exact same, except instead of y, I now have f of x. So your y and f of x are the same thing. They're the same. Except now we have a function notation. We're in function notation. We're using function notation. All right. So for evaluate, here we have a third vocabulary word, except I'm not going to define this one again, but let's pretend I ask you to evaluate something. Let's say x equals 5, and then we have the function y equals 3x plus 5. Well, if I know x equals 5 and I ask you to evaluate that, I'm going to say, well, given the information that I have been provided, I'm going to go ahead and plug in 5 for x. So then I have y equals 3 times 5 plus 5. So I'm going to take this, I'm basically plugging it in for x. And then I have 15 plus 5, which gives me 20. So y equals 20. So that's basically evaluating. Given something, I'm going to plug it in. All right. You might have heard me pronounce it earlier, but that f with the parentheses and an x inside is read as f of x. So if you were trying to read it, it would be f of x. And like this would be g of x or f of h. So it's just of something. So something of something. So later on in the second half of the notes, where I'll make a separate video, we'll have an a and a 1. So this would be a of 1. So that's just kind of how it's read. All right, down here I have a t-chart for input and output. So input is something that you're putting into the function, and output is what you're getting back out. So like earlier, I put a 25 in the square root, and I got back out a 5 and a negative 5. So I had two outputs, one input. So your input is going to be your x values. You're plugging stuff in for x. It's the independent variable I can input stuff. The output is going to be my y values, all of my dependent variables. So they depend on my x values. Another word for input, all of our x values are also known as domain. So this is something from the last lesson. And then output would be range. So if it asks you to find the domain, it's asking you to find x or find the input. If it's asking you to find y, it's asking you to find the range or output. So sometimes they give you the input and they ask you to find the output. And sometimes they give you the output and ask you to find the input. So it really just depends, and we'll kind of see that later on in the notes. All right, so our first example and the second example are very similar. One's in normal notation and the second one's in function notation. So number 1, how would we evaluate the following equation if x equals 6? And I'm given y equals 3x plus 1. Well, if I know that x equals 6, if I know it equals 6, then I'm going to plug in 6 for my x value here. So I have y equals 3 times 6, so it takes place of the x, plus 1. So everything is changing, or everything stays the same except for the 6 that I'm plugging in. Why don't I plug in 6 for y? Well, x equals 6. It's not y equals 6, x equals 6. So you plug it in for the x value, anywhere you see an x value. Also notice I use parentheses. So anytime you plug in, you want to use parentheses. It causes less room for mistakes. All right, moving on. I'm going to have y equals, well, 3 times 6 is 18, plus 1. So then y equals 19. So that's my answer there. So what is our input? Our input is what we put into the equation, which was 6. Our output is what we got out of the equation after we've plugged in, which is 19. So we have an input and an output. This is kind of like when we did parent functions and you had to look on XY table. Your calculator is basically doing all of this for you. So all this math that we just did, it did it for us in the calculator. We didn't have to do that. But if I ask my calculator, hey, if I have an x value of 6, what happens with my y value? It'll give me 19. So basically it's a way that we can make the table just by hand instead of using a calculator. All right, evaluate the following function for f of 6. Okay, well, we now have f of x equals 3x plus 1, which is very similar to the equation we had last time. So we had y equals 3x plus 1 here, and then f of x equals 3x plus 1. So the only difference is that we've replaced y with f of x, but again, they're the same thing. Okay, f of 6. What does f of 6 mean? Well, this took place of our x value, right? Because it was f of x. So if it took place of the x value, that means that my x value is 6. It's saying that x is 6. It plugged in a 6 for me. So if x is 6, I'm going to plug in a 6 for anywhere I see the x. So I have f of 6 equals 3 times 6 plus 1. So anywhere I saw a 6, I went ahead and I changed it to, let's actually change that to blue. Anywhere I saw an x, I changed it to 6 because that's what it says. It says f of 6. So anywhere I see an x, I'm going to plug in a 6. Now, let's talk about this. This side right here literally means nothing. It's kind of irrelevant because what it's basically saying is, hey, I'm plugging in a 6 into my function. It doesn't do anything. You're not solving or simplifying anything over there. It's not f times 6. It's nothing. It's just saying, hey, x is 6. I'm plugging it in. That's all you're doing. So it's kind of irrelevant for our purposes currently. So then we continue math like normal. 3 times 6 is 18. And then we have plus 1. So lastly, we have 19. So we have f of 6 equals 19. What does that mean? It means when I plug in a 6 for my x, I get out 19, which is the same answer I got from the previous problem, except the previous problem didn't use function notation. So this is no difference except for the way that it's written, but the problem is the same. All right, so now we're going to practice with a little bit of more using an input and using function notation. So we're given 3 functions here, f of x, g of x, and h of x. And we're given 3 different problems to kind of figure out. So we want to find f of 4, h of -2, and g of 6. Okay, well, for the first one, for f of 4, which function am I going to use? The first, the second, or the third? I'm going to use the first. And the reason I'm using the first is because these both have f's. So you want to make sure that you're using the correct function with the right one. You don't want to plug it into the wrong function. So I'm going to use f of x equals -2x plus 5. So this is the first function I'm going to use. Anywhere I see an x, I'm going to plug in a 4 because it says f of 4. My x has been replaced with a 4. So f of 4 equals -2 times 4 plus 5. And if you're not taking notes, you're wrong, so make sure you're taking notes. All right, again, f of 4 means nothing. It just means I'm plugging in 4 for my x. And I'll continue simplifying like normal. -2 times 4 is -8, and I have -8 plus 5, and that's going to be -3. So what does that mean? It means if I have an input of 4, I'm going to get out -3. You can also write this as f of 4 equals -3. There's not really a wrong way to write it, but I need to explicitly know that you understand that, hey, if I plug in a 4, I get -3 for my output. So input was 4, output was -3. All right, the next problem, h of -2, I'm going to use the h of x function. So the h of x function is 3x squared plus 2x. Okay, I have an input of -2 here, so h of -2 equals 3 -2 squared plus 2 times -2. And I know it sounds like I'm saying a lot, but I'm just reading what I'm writing down. Anytime you plug in, make sure you use parentheses, especially in the calculator, because you will get it wrong, especially if what's inside your parentheses is a negative. All right, this is a step that people kind of miss a lot or mess up. So PEMDAS says to do what when we're simplifying? We're going to do parentheses first, and if I look at these parentheses right here, there's nothing else I can simplify. It's just -2. The next thing in PEMDAS is exponents. So before I multiply the 3 in, I need to do my exponents. So this is going to be 3 times 4, because -2 squared is 4, positive 4. Okay, so nothing has changed. So, oops. So this is now this. Okay, and now I'm going to continue my math like normal. 3 times 4 is 12. 2 times -2 is -4, and that's going to give me 8. So my answer here is 8, or h of -2 equals 8. All right, the last function, I have g of 6, so I'm going to use the g of x function. So it's going to be g of x equals 2/3 x minus 1. If you do not know how to use the fraction feature in your calculator, please come in and I will definitely help you. But for the purposes of this video, we're just going to be like, hey, I already know. So g of, different color, g of 6 equals 2/3 times 6 minus 1. Sorry, my hand's like rubbing against the table. It's making noises. All right, 2/3 times 6 is 4, and then I have minus 1. And then that's going to equal 3. So g of 6 equals 3. So that one wasn't too bad. All right, so that's what we're doing basically here. If you're given a function that says f of something, you're going to take that something and plug it into that function. All right, moving on, we have evaluate the function with the domain -3, 0, and 6 to find the range. Okay, so let's dissect this information. We're asked to evaluate a function with the domain -3, 0, 6. So we are given the domain of -3, 0, and 6. Now domain is what values? It's our x values. So they're giving us x. They're giving us -3, 0, and 6. We're given 3 x values. And they're asking us to find the range. They said find the range, and the range is our y value. So we're given x, find y. Well, what is k of x the same thing as? If f of x is the same thing as y, then k of x is also technically the same thing as y, right? It's the same thing. Given x, find y. So, in the first problem here, well, let's talk about this. What does this little curly braces mean? Well, it's just listing out some x's for me. Domain, -3, 0, 6, which means I have 3 x values. I have x equals -3, I have x equals 0, and I have x equals 6. So they're giving me 3 x values. And I'm going to take each of those x values and evaluate. So I'm going to do x equals -3 first. Okay, well, what does that mean? I'm going to plug in -3 for all of my x values. So I'm given k of -3 equals 7 minus 2 -3 squared. So I took the function that they gave me, and I'm plugging in a -3 for all of my x values. Like I said earlier, this part here means nothing. It's just saying, hey, I'm plugging in -3 for my x, nothing else. All right, so this is going to be 7 minus, okay, now PEMDAS again says to do parentheses and then exponents next. So before you do -2 times -3, you need to do -3 squared. So -3 squared is going to be positive 9. Okay, and then after that we can continue. We have 7 minus 18, because 2 times 9 is 18, and then 7 minus 18 is -11. Now go ahead and box an answer for now, but I'll go ahead and show you how to write the answers at the very end. Okay, the next x value that I'm going to plug in is 0, because I have given 3 x values, so I need to plug in all 3 of them. So I did -3, now I got to do 0. So when I plug in 0 for my x value, I'm going to do k of 0 equals 7 minus 2 times 0 squared. Anywhere I see an x, I plug in a 0. Again, it just means you're plugging in 0. Literally irrelevant. Doesn't mean anything. 7 minus 2, well, 0 squared is 0. Okay? And then negative 2 times 0 is just 0. So this is just really 7 minus 0, which is 7. And this step right here isn't really necessary, but if you want to write that, then you can go ahead. Not going to judge, you know. All right, let me highlight right here so we know where that came from. All right, and then I have one more x value to plug in, which is 6. So x equals 6. So I have k of 6 equals 7 minus 2. Plug in a 6 there. And then I have 7 minus 2, and then I'm going to do 6 squared, which is 36, equals 7 minus 72, which equals 65. Oh, negative 65, actually. All right. So now I have 3 y values, because they gave me 3 x values, and then it spit back out. My range gave me 3 y values. So I'm going to write that with my curly braces. So just like they gave us the negative 3, 0, 6 in curly braces, I'm going to use curly braces here. And I'm going to list them in the order that I plugged it in. So when I plugged in negative 3, I got out negative 11. When I plugged in 0, I got out a 7. And when I plugged in 6, I got a negative 65. And that's what my range would be. So they gave me a domain, and I'm giving them back a range. All right, the next problem is evaluate the function with the range negative 1, 5, 23 to find the domain. So this time, it gives me the range, and range is what? Ranges are y values. And then it wants me to find the domain, which is x value. So this is the opposite of what the last problem was. The last problem, it said find the range. This one says find the domain. So this is kind of like the opposite. So you want to make sure that you're reading very carefully, because the math isn't too bad. It's the fact that we sometimes read the wrong stuff and then we do it wrong. So it says given the range. So we're given y. Well, what is h of x the same thing as? H of x is the same thing as y, right? Because those are our y values. It's the range. So I'm going to go ahead and rewrite this as y equals 5 minus 3x. Okay, and then I'm given 3 y values. I'm given y equals negative 1, y equals 5, and y equals 23. So I'm going to do y equals negative 1 over here, y equals 5, and then y equals positive 23. Okay, well, I'm given the range, so I'm given my y values, so I'm going to plug in the y values. So this is going to be negative 1 equals 5 minus 3x. So I'm plugging it in for my y values. Okay, I'm going to solve for x. So this is basically the first day or second day where we solve equations. So the next step here is to subtract 5 from both sides. Negative 1 minus 5 is negative 6 equals negative 3x. Divide both sides by negative 3. X equals 2. So box that for now. I'll write the answer later. Okay, here I'm going to do the same thing except for y. I'm going to plug in a 5. And if you're wondering where all of these other things are coming from, remember we're using this equation and just plugging in whatever y value we have next. So here I'm going to have 5 minus 5, and that goes away because that's 0. And then I also have 5 minus 5 on the other side, which also gives me 0. So we want to make sure we write the 0. Then you're going to divide both sides by negative 3. So you have x equals 0. All right, last one, same thing. We have 23 equals 5 minus 3x. First step again is going to be to subtract 5 from both sides because we want to get the x alone. 23 minus 5 is 18. Divide both sides by negative 3. And I get x equals negative 6. So these are my x values. So it gave me the range negative 1, 5, 23. And now I'm going to give it back to it in the same format. So when I had the output of negative 1, I now had the input of 2. They gave me the output of 5, I had the input 0. They gave me the output 23, and now I have the output of negative 6. So this time they gave me the output, and I had to find the input. So you're given the range, find the domain. So those are just different words, but it's basically the opposite of the last problem. Same process, but the opposite, because you're plugging in y instead of x this time. All right, we're going to do these 2 problems, and then after these 2 problems, I'm going to cut the video and then start the next section. All right, so here we're given g of x equals 4x minus 2. We need to find the input when g of x equals 18. Now, on the side of your notes, I would like you to write a very important note. Come on, zoom in. Okay. F of 6 is not the same thing as f of x equals 6, right? So that little equals with the cross means does not equal. So f of 6 means x equals 6. This one means, well, what is the same thing as f of x? Y. This means y equals 6. X equals 6 and y equals 6 are not the same thing. So you can't just plug in that 6 to any x value or anything that you want to do. So they're not the same thing. Okay, so here we're given a function and we need to find the input. The input is what? The input is x values. So we're asked to find the input, which means they're probably giving us the output, saying g of x equals 18. Well, if g of x equals 18, if g of x equals that, then I'm going to plug in 18 for g of x because it's saying g of x is 18, saying y is 18, okay? So you're not going to put g of 18, you're going to literally plug in 18 for your g of x. So that g of x is no longer there. And now you just have an equation. You're asked to find the input, which is x, and that makes sense because I have an x variable that I have to solve for. Don't plug in 18 for x. It's not saying x is 18. And I'm stressing this because these are the problems that we miss a lot. All right, and here I'm going to solve like normal, so I'm going to add 2 to both sides to get x by itself. 20 equals 4x. And I'm going to divide both sides by 4. Actually, I don't know why I divide by 5. 4. So I have 5 equals x. So my input is 5, right? It says find the input, 5. So that means the output is 18. So the output was 18, and they wanted us to find the input, which is 5. All right, the second one is actually pretty similar. Given p of t equals t squared plus 3, find the input when p of t equals 39. Input is x. It says p of t is 39, so this p of t is 39. I'm replacing it. It is no longer there. Okay. Next step here, I'm going to subtract 3 from both sides, and I get 36 equals t squared. Now, how do I get rid of a square? Well, the opposite of squaring something is square rooting it. And when I square root something to one side, I have to do it to the other side. And when I square root, all I have left is a t. And then the square root of 36 is 6, so that's one answer. However, when I square root, remember I get 2 answers, right? 6 times 6 is 36. But also, negative 6 times negative 6 is 36. So there's 2 answers here technically. So I'm going to go ahead and move this down. Oh. So I actually have 2 answers here. I have 6 and I have negative 6. All right, so that's all of the notes for evaluating functions. The pre-P section will be in a separate video, so you don't have to worry about that. If you have any questions over just evaluating functions, please let me know.